Okay, so here we have a Diophantine equation asking about how many notes we've got in our wallet. Okay, now it has to add up to $200, and we can't have fractions of notes. Unfortunately, people don't accept half a $20 note and say that's $10. So there must be integer values of those two things. Now, X is the number of $50 notes, Y is a number of $20 notes. So my dollar value will be 50 times the number of $50 notes plus 20 times the number of $20 notes has to equal 200 in total. So that means I'm going to divide these both by 10 first. So that means otherwise it gets harder. So 5x plus 2y equals 20. So in other words, if you up the top here, I wrote d is equal to the highest common factor of those two numbers. So hopefully this makes it clear to you what d is, okay? And also that means that my a on d now is equal to 5 and b on d is equal to 2. Now, it's not hard to think about this one, like to find the value, one of the values it could be. I could use either of the notes, but let's start with the $50 notes. 4 of them, so 5 times 4 equals 20, right? So my x naught will equal 20, and equal 4, and if that's true, then y naught will have to equal 0, okay? Because 4 times 5 is equal to 20. So using the laws of the Diophantine equations, in other words, so x is going to equal a on d, not a on d, sorry, x will equal the x naught plus a on d. Sorry, b on d, so the b goes to the x, my mistake, times t, and all my y values are going to equal y naught minus a on d times t. Okay, so I can try all little steps of t. So let's rewrite that. So my x is going to equal 4 plus b on d is 2t, and y will equal 0, which doesn't matter, minus 5 times t. Okay, 5 is a on d. All right, so the other thing to remember is that we can't have negative, it's not a bank account, we can go into debt. Notes are physical things, so we can't have negative $50 notes or $20 notes in our wallet. So x has to be greater than or equal to 0. Which means that 4 plus 2t is greater than or equal to 0, which means that 2t is greater than or equal to minus 4, or t is greater than or equal to minus 2. Also, y has to be greater than or equal to 0, so minus 5t has to be greater than or equal to 0. And don't forget, if I divide by a negative, flips it around, okay? So y has to be less than or equal to 0. T has to be less than or equal to 0. So I've got t has to be greater than 2. So that means now, because of this, that minus 2 is less than or equal to my t value, and which is also less than or equal to 0. So if I use my initial thing, hang on, let me just add the extra bit of room here. So now, following on from this, so all possible values are, so t has to be between -2 and 0, okay? So x could be equal to 4, possible values of x are, so let's just, actually I might write this as a table. So these are my t's, this is the x, and this is the y available to them. So t has to be 0, -1 or -2. If t is equal to 0, then x is equal to 4, and y is equal to -5 times, there's nothing. And if x is, t is equal to -1, then x is equal to 2, and t is equal to -1 times -5 is 5, and so on. Okay, if you follow that down. So my possible values are, well, you can say I could have 4, 0. Well, you could write this out a bit more formally. So either 4 times $50 notes and 0 of just 4 times $50 notes, or 2 times $50 note and 5 times $20 note, and or the other chance is that we've just got 10 times $20 notes. Okay, there you go, that's the example.